Good morning. All right, so we're going to finish up section 1.5 today. We've got a couple more examples there that we need to do. Then we're going to jump over to 1.8 because we'll skip over 1.6 and 1.7. 1.6 we do come back to when we do chapter 3. 1.7 we just won't cover it all. Okay, so 1.5 we'll finish up, get into 1.8. So that means that you can at least get started on the 1.5 through 1.10 homework. That due date is right now been moved to next week, like middle of the week. We'll kind of see how far we get between now and Wednesday of next week, and if I need to push that back even further. But again, the goal for right now is to try to finish up 1.5, 1.8, and then 1.9 and 1.10 in next week, so that I can get that test posted and either have it due end of next week or at the worst the beginning of the following week. Okay, so that's kind of the goal right now. Any questions, comments, concerns, though, before we get started today? All right. So let's look here at example 11. All right, so the first thing we want to do here, we're trying to solve this equation, and notice that we've got this square root in our equation. Anytime you see an equation with a square root like that, the first thing you're going to want to do is try to isolate the square root, get the square root by itself. So to do that for this one, what am I going to have to move first if I want to get the square root by itself? The 1, good. All right, so I'm going to move the 1 to the other side, so I'm going to have to subtract it. So that's going to give us 2x minus 1 is equal to negative square root of 2 minus x. Now, at that point, what we want to do is try to get rid of that square root, right? You might be saying, well, there's a negative in front. Well, how are we going to get rid of the square root here? What would you have to do to get rid of a square root? Okay, so that's one thing you could technically do, right? But if you do that, then we're just going to introduce a square root on the other side. What if I just want to get rid of the square root altogether and introduce another one? We can square it, right? So if we square both sides of this equation, that's going to get rid of our square root, and it's not going to introduce another square root anywhere. And by squaring the right-hand side, that'll also get rid of the negative, right? So we don't have to worry about the negative here, because once I square this, the negative is going to go away anyway. So my next step is just to square both sides of that equation. All right, now we just need to simplify what we've got here. So if I do 2x minus 1 squared, what is that going to give us? Okay, almost, right? So let's write this down twice, right? And then we'll use FOIL. So this is 2x minus 1 times itself. And then what are we going to be left with on the right-hand side once we square that? Okay, so remember the negative when we square it goes away. So all that's going to be left now when I square that square root is whatever's inside the square root. So it's actually going to come out just a 2 minus x. Okay, and that's right, Alexander. So that middle term needs to be a minus 4x, right? So now when I FOIL on the left, right, 2x times 2x is going to give us 4x squared. The outer terms will give us a minus 2x. The inner terms will also give us a minus 2x. And then the minus 1 and minus 1 should give us a positive 1. Okay, so I'm going to pause right there. Any questions up to that point about how I got any of those terms now? Okay, all right, so then like Alexander said, we can combine those middle terms, so that's going to give us 4x squared minus 4x plus 1 equals 2 minus x. Okay, and now notice we have a quadratic equation, right? This one has an x squared in it. So what are we going to want to do next to solve this quadratic equation? Okay, now before we can factor, what do we have to do? We've got to move the 2 and the minus x, right? Because we got to move everything to one side, set this thing equal to 0, then we can try factoring. So I'm going to subtract the 2, and I'm going to add the x. So over here, we're going to subtract the 2, and we're going to add the x. So now we have 4x squared. That middle term is going to be minus 3x, and then a minus 1. Now that we've set it equal to 0, now we can try factoring, right? So what could I try here to get the 4x squared? Okay, it could be a 2x times 2x, or it could be 4x times x, right? Those are my two options. Let's go ahead and look at that last term. What are the options to give us a 1 now? 1 and 1, right? Okay, and in this case, one of them is going to have to be positive, one of them is going to have to be negative, because we know we want a negative 1 this time. Now it's just a matter of figuring out, do we want to use the 2x and the 2x or the 4x and the 1x? Which one do you want to try first? Okay, so let's go with 4x and 1x. Now just to check to make sure this is the correct factors, 4x times x would give us 4x squared. Outer terms here would give us a negative 4x. Middle terms or inner terms are going to give us plus x, and last terms minus 1. Combining our terms here in the middle, that's a negative 3x. That's what we started with. That is the correct factored form. Okay? And again, if that doesn't work, then just go back and switch your terms around or try the other two, the 2x and the 2x, right? But in this case, those are the factors. Now, once we have our factors, now what do we need to do? Good. Set each factor equal to 0. So we got 4x plus 1 equals 0. X minus 1 equals 0. So then what are we going to get when we solve that first one? Good. So we subtract the 1, which is negative 1, divide by the 4, and so we get negative 1/4. All right, and then what about the other one? Good. So add the 1, and we just get x equals positive 1. Absolutely, right? So quadratic formula always works, even if the thing does factor. So if you want to use quadratic formula instead, that'll give you the exact same answers we just got here by factoring. And again, completing the square is another option, right? So completing the square would also give you the same answer if you don't see how to factor it. All right, now on this problem, similar to the problem that we did last class where we had to go back and check, we have to do the same thing here. And the reason is at this step up here, when we squared both sides, it's possible that we introduce something that doesn't actually work. Okay, so we have to take the values that we got, plug them back into the original equation, and make sure they actually work. So I'm going to start with a negative 1/4. We're going to have 2 times negative 1/4 equals 1 minus the square root of 2 minus negative 1/4. Okay, so if we multiply 2 times negative 1/4 on the left, what is that going to give us? Good. This is negative 1 over 2, because that would be negative 2/4, right, which would simplify to negative 1/2. On the other side now, if I simplify what's inside the square root, 2 minus a negative 1/4. Well, minus a negative becomes addition, right? So we know we're adding. So what's 2 plus 1/4 going to give us? Almost, right? So let's think about the 2. If I find the common denominator here, what is 2 going to become? Okay, so it's going to be 8 over 4 for the 2, and then plus 1 over 4. And so then when we add those together, it's going to give us 9/4. Okay, now what is the square root of 9 over 4? Three halves, right? Because we can take the square root of the numerator, take the square root of the denominator. And so now we're going to have negative 1/2 equals 1 minus 3 over 2. And now what's 1 minus 3 over 2? It's going to give us negative 1/2, right? Because 1 would be 2 over 2. And so this gives us negative 1/2. That's what we were trying to get to. So this one actually checks out. And so negative 1/4 actually does work in that equation now. Now we need to check the 1. Okay, so now I'm going to plug in 1 back into the original equation. We're going to have 2 times 1 equals 1 minus the square root of 2 minus 1. Okay, well, what's 2 times 1? Good. And then we have 1 minus. We're going to have the square root of 1 there, right? Well, what's the square root of 1? 1. And now on the right-hand side, when I subtract, what are we going to get? 0. Are those equal? They are not, right? So this is not a true statement anymore, and that tells me now that this x equals 1 does not work. That's why we have to go back and check, because it's possible that one of the values that we get down here, or sometimes both, right? It's possible that both of them won't work. We always need to go back and check to see if they do, right? So it could be that both of them do work, both of them don't work, or it could be that one works and one doesn't. Now, one that doesn't work, so this one right here, we call this an extraneous solution. Okay, so if you ever hear that term, that's what it's referring to. And if you look at the root of that word extra, right, it's basically an extra solution that does not actually work as a solution to the equation. The only answer here is x equals negative 1/4. So what I would say is that the main times that you're going to want to check is if you have a rational equation to begin with, right? So if you think back to the one we did yesterday where we had the fractions with the x's in the denominator, that's a time that you're going to want to check, because in those cases, it could be that your solutions are actually undefined. And so you do want to plug back in. Also, when you have square roots in your equation and you have to square both sides, that's another time that you would want to check, because it's possible when you squared that you introduce something that shouldn't be there. Okay. So I'd say those are the two main cases where you're really going to want to go back and check your answers. Fractions with x's in the denominator, and anytime you square to get your solution with a square root. Yep. Any other questions there? All right. So we're going to do one more here. It's just this last one here. Okay. So now we got an absolute value equation. All right. So we want to solve absolute value of 2x minus 5 is equal to 3. Now, here's what I want you to think about. If I know the absolute value of something is equal to 3, what could be inside the absolute value that would give you 3? So what number or numbers could I take the absolute value of and get 3? Okay, so don't quite go that far because you're giving me the solution, right? So I just want to know in general, inside that absolute value bar now, right? What numbers could I have inside there? Ignore the 2x minus 5. What number or numbers could I put inside the absolute value bars would give me 3? Either a negative 3 or a positive 3, right? So I know in this case that whatever's inside here now has to either be a negative 3 or a positive 3, so that when I take the absolute value of it, it's going to give me positive 3. Now I can set up my two equations. So this 2x minus 5 here either has to be equal to 3, or the 2x minus 5 has to be equal to negative 3. Because those are the two things I could get inside there and still get a positive 3 once I take the absolute value. Now we just have to solve each one of those equations. Okay, so if I look at this first one, what's the first thing I'm going to do here? Good, add the 5. So if I do that, that's going to give us 2x is equal to 8. And then we would have to do what? Good, divide by 2, so x equals 4. There's one solution. Then on the other side, same steps, right? So when I add 5 here, what's that going to give us? Good. And then once I divide by 2, x is going to be equal to what? 1, right? And that was that solution that you were giving me before, so that's good. So those are now the two solutions to this equation, because if I substitute in a 4, 2 times 4 would be 8, minus 5 would be 3. Absolute value of 3 is equal to 3. That checks out. If I substitute in 1, 2 times 1 is 2, minus 5 is negative 3. Absolute value of negative 3, though, becomes a positive 3, so that checks out. And so now I get two solutions here, and both of these numbers would actually give us 3 as our answer. So in general, when you're solving an absolute value equation, once you just have a number on the right-hand side like that and your absolute value by itself, all you're going to do is set what's inside the absolute value equal to the number itself and its opposite, right? So in this case, 3 and negative 3, and then just make sure you're solving. Any questions on that one now? All right. Like I said, that's all we're going to do in section 1.5 now. Let's jump over to 1.8. There we go. All right, so in section 1.8, we're going to deal with inequalities now. So a lot of the properties that we use for solving equations are still going to apply to solving inequalities. There's going to be one additional thing we have to consider when we're solving inequalities now. Okay, so notice here our rules for inequalities. We still have that addition rule, right? We can add the same thing to both sides and the inequality is still true. Number 2 says we can still subtract the same thing from both sides. Inequality is still true. Here's where things get a little different. Okay, so it's right here. If we multiply both sides by a positive value, right? So notice here, the C value is greater than 0. That means it's positive. Then our inequality is still just going to maintain, right? So we multiply both sides by a positive value. C times A is still less than or equal to C times B. Nothing changes. It's when we start multiplying by something that's less than 0, in this case that would be a negative value, notice here that this sign that was less than or equal to now becomes greater than or equal to. Basically, anytime you multiply, in this case, or divide by a negative value, we have to remember to flip that sign. Okay, so that's just one of our rules for inequalities now. If you multiply or divide by a negative, make sure you flip your sign. And then these other ones here, they're just kind of nice to know, but not really extremely important in solving the inequalities. Okay, but if we have an A and a B value, both being positive in this case, and A is less than or equal to B, then the fraction 1 over A has to be greater than or equal to a fraction 1 over B, right? So if you say something like 1, or let's do 2 and 3, 2 is less than or equal to 3, therefore 1 over 2 has to be greater than or equal to 1 over 3, right? So 1/2 is bigger than 1/3. That's all that really says. And then if we have an A value less than or equal to a B value and some C value less than or equal to D, then the sum of A and C would have to be less than or equal to the sum of B and D, right? So if I put this smaller value and this smaller value together, it's going to have to be less than the two bigger values added together, or equal to, right? And then finally, this is what we call the transitive property. If A is less than or equal to B and B is less than or equal to C, then this first value has to be less than or equal to that last value. But again, the first 4 are the main ones we need to focus on. And again, the main one is that number 4. When we multiply or divide by a negative value, just don't forget we have to flip that sign. All right, so now we want to solve this inequality. We've got 3x is less than 9x plus 4. And then once we solve it, we're actually going to sketch the solution set. And I'll show you what we mean by that in just a minute. All right, so in general, like I said, the properties here are the same. So I still want to just get x by itself. So what am I going to do first if I want to get x by itself here? Okay, could, right? We could move the 3x to the other side, but then we'd still have to move the 4 away from the x. Or like Luke said, we could move the 9x over, right, and go ahead and combine it with the 3x that's already there. So that's going to create the fewest steps for us this time. So I'm going to go that way. I'm going to subtract 9x from both sides. Now, once we do that, what's 3x minus 9x? Okay, it's going to give us a negative 6x, right? Because we're just subtracting 9x from 3x. This is still going to be less than, and then all that's left on the other side is the 4. Okay, and now to get x by itself, we're going to do what? Okay, good. Divide by negative 6. Okay, so divide both sides here by negative 6. So that's going to give us our x value. What's our sign going to be? right. So in this case, because we divided by a negative value, we have to flip that sign. So now instead of less than, it becomes greater than. Now if we simplify 4 over negative 6, what's that going to give us? Good. Negative 2 over 3. So there's our solution. Now, it also wants us to sketch that solution set. Okay, so in this case, when I draw my number line, that's how we're going to draw our solution set. I'm going to put the value that we've got here. So in this case, negative 2/3. Now I have to determine if this is going to be an open circle or a closed circle at negative 2/3. So what do you think? Open or closed? Good. It's going to be open because this is strictly greater than negative 2/3, not greater than or equal to. Right? If there was an equal to there, then we would close that circle in and include it. Now, which way am I going to shade on my number line if I want x to be greater than negative 2/3? To the right. Good. So now I'm going to shade everything on my number line to the right of negative 2/3. So that is the sketch of my solution set now. So notice there's an infinite number of values here that would make this inequality true, and all of them have to be greater than negative 2/3. That's what this tells us. Any questions on that one now? All right. Let's take a look at this one. Okay, so now we've got what we call a compound inequality. We've got 4 less than or equal to 3x minus 2 less than 13. Now, there's basically 2 options here. We could either leave it all as a compound inequality and solve it all together, or you can split this up into 2 separate inequalities and solve both of them, right? It's up to you. It does not matter. Neither one of them is going to be more work than the other. Okay, so just so you know, if you wanted to split it up, it would look like this. 4 is less than or equal to 3x minus 2, and 3x minus 2 is less than 13. Okay. So if you wanted to split it up, that's what it would look like. So the middle part becomes part of both inequalities, right? The signs don't switch or anything. It stays exactly as is, but it becomes an and statement because now both of these inequalities have to be true for that original compound inequality to be true. Now, I'm going to show you we can actually solve this simultaneously by just doing the same thing to all 3 parts of our inequality. So if I want to get x by itself here, what would I have to do first? Okay, we got to get rid of the 2. Good. So in this case, to get rid of that minus 2, I'm going to add 2. Now, because we're technically solving 2 different inequalities simultaneously, when I add that 2 in the middle, I have to add it over here, and I have to add it over here. That's the key to solving these things at the same time, is just to make sure that whatever you do in the middle there, you're also doing on the left and the right. Okay, so now we got 4 plus 2, which should give us 6, less than or equal to 3x, which is less than 15. Okay, now what do we need to do? Good. Divide by the 3. Same thing, once I divide by the 3 in the middle there, I have to come over here and divide this by 3, and I have to come over here and divide this by 3. So now we have 6 divided by 3 is 2. What about my sign this time? Stays the same. Good. I did not divide by a negative, so that's going to stay less than or equal to. Now I have my x. Same thing over here. 15 divided by 3 is 5. I did not divide by a negative, so that sign stays less than. Right, so this right here is our solution now. Now, just to show you, right, if we had done it the other way, we would still add the 2 over here. That would give us 6. We would divide by the 3. That would give us 2, less than or equal to x. And then over here, we would do the same thing. 3x is less than 15. Divide by 3, x is less than 5. And so we have this inequality and this inequality. But that's exactly the same thing we have here. They're just combined into one compound inequality. All right, now let's think about what this solution set would look like graphically. Even though they don't ask us to graph it, there will be some in the homework where they do, just so we can see it. So what are we going to have to put on the number line this time? Two and 5. Good. So we need the 2 and we need the 5. What are we going to have on the 2 this time? Open or closed? This time it's going to be closed, right? Because this is less than or equal to 2. A closed circle. And then what about the 5? That one's going to be open. Good. And then where are we shading this time? It's going to be in between, right? So if you notice here, I'm going to flip this first one around. This is actually x is greater than or equal to 2. If I just flip the whole thing around. So I need to be greater than or equal to 2, but also less than 5. Well, if I'm greater than or equal to 2 and also less than 5, that's everything that's in between 2 and 5 now. So that's what my graph would look like. And then if you wanted the interval notation for this one, what would that interval notation look like? Good, right? So we'd have a bracket on the 2, parentheses on the 5. And so this is the way I'm going to ask for most of your answers, right, is in interval notation. So just get familiar with that. And if you need to draw the number line to help you get to the interval notation, right, then definitely do that. Or if you can just go straight from that inequality to the interval notation, that's fine too. All right. Any questions on how we did any of that now? All right. All right, so the sign of a product or a quotient. Okay, so if a product or a quotient, meaning multiplication or division, has an even number of negative factors, then the value is going to be positive. Right? And so you can think of it this way, right? If I multiply a negative times a negative, that's going to be equal to a positive, right? And that's an even number of negatives. I have 2 negatives there. That's always going to give you a positive. Same thing if I had 4 negatives, that would still give me a positive. If I had 6 negatives, it's still going to be positive. However, if I have an odd number of negative factors, then the answer should come out negative. So if I have something like negative times negative times negative, that's an odd number of negatives. Overall, that's going to give us a negative. Now, the reason this is important is because if we can just figure out in terms of our factors which ones are positive, which ones are negative, then we can just count up how many factors are positive, how many are negative. If we get an even number of negatives, we know it's positive. If we get an odd number of negatives, then we know it's negative. And we don't have to know the exact value of whatever we're dealing with. just the signs. Okay. Now, in general, we're going to be solving some nonlinear inequalities now, right? So the first two that we did were both linear. It was just x to the first power. Now we're going to look at things that have higher exponents and also some fractions. In terms of those inequalities, you're always going to move everything to one side first. Okay, so get 0 by itself on one side, move everything else to the other side. Then we're going to see if we can factor, right? So we always want to try to factor as much as we can. Once we create those factors, then we're going to generate intervals based off of the factors that we create, right? And that'll make a little more sense once we actually do the problem. Then it says we're going to make a table or diagram. I'm going to use the table and I'm going to do a number line, right? Just so we can kind of see how we can use both of those to help us solve this. And then it says we're going to solve, right? And the way we're going to solve is by looking at those positives and negatives to determine which intervals actually work now. Okay, so let's take a look at this one. We've got x squared less than or equal to 5x minus 6. All right, so first step, it is a nonlinear inequality, right? Because this is an x squared. It's not an x to the first power. The first thing it told us to do in our guidelines is we want to get everything to one side. So I'm going to move everything to the left-hand side this time. So I'm going to subtract 5x, and I'm going to add 6. I'm going to come over here, and I'm going to do the same thing. So now we have x squared minus 5x plus 6 less than or equal to 0. All right, now once we've moved everything to one side, what are we going to do next? Factor. Good. So I'm going to try to factor this. All right, so what are my factors going to look like this time? Good. So we need an x and an x to give us the x squared, 2 and 3 to give us the 6. And in this case, we need the signs to be the same. We need a negative 5x in the middle. So it is going to be negative and negative. So x minus 2 and x minus 3 would be our two factors. All right, now, once we have our factors, we don't want to set them less than or equal to 0. We actually want to take each one of our factors now and set it equal to 0 instead. Okay, and I'll show you why in just a minute. We've got x minus 2 equals 0, x minus 3 equals 0. Okay, now, if we solve both of those, what are we going to get as the x values from each of these equations? 2 and 3. Good. The 2, we get x equals 2. Add the 3, we're going to get x equals 3. Now, at that point, what I'm going to do is I'm going to draw a number line. And I'm going to put those two values that I just got there on my number line. And eventually we'll do some that have even more values to put on the number line than that. Okay, so for right now, we just have two values. We're putting both of them on the number line. Now, I'm going to create a table over here that divides up the intervals that I've created from that number line. This table is not a requirement, right? So it's helpful if you want to use it, but if you don't and you can do it just using the number line, by all means, that's perfectly fine with me. I have 3 intervals that I've created here. So what would the first interval look like based off of the divisions that I've put on my number line now? I'm looking at this interval right down here. It's going to go from negative infinity to 2. So we're going to have an interval here from negative infinity to 2. Right, what's the next interval going to look like? From 2 to 3. Good. And then our last interval is going to be what? 3 to infinity. Good. So that's my first step, is to draw my table, figure out how many intervals I've created by putting the numbers on the number line, and then just label each one of those intervals. Now I'm going to list my factors down the side of my table. Now, I need both factors that I've got there and the product of those factors. So that means I'm going to put x minus 2, then I'm going to put x minus 3, and then my last line here is going to be the overall x minus 2 times x minus 3. So you're always going to have one more line than you have factors, right? Because the last line is always going to be the combination of all of your factors. Right, now at that point, I need to choose a value in each one of my intervals to test. So I'm going to start with this one right here, the negative infinity to 2. What's a number that would fall in that interval? One, okay? Let's go with 1. So what I'm going to do now is I'm going to come back to my inequality up here in factored form, and I'm going to substitute in that test value. So I'm going to plug in 1. That's going to give us 1 minus 2 times 1 minus 3. Now, I don't care the exact value. I just care whether it's positive or negative. Is 1 minus 2 going to be a positive value or a negative value? Negative. Is 1 minus 3 going to be a positive value or a negative value? How many negatives do we have? Is 2 an even number or an odd number? And so if it's even number of negatives, we know that overall this should be what? Positive or negative? It's going to be positive, right? And so that tells me that everything in this interval here, well, sorry, should have listed it out in the table, right? The x minus 2 gave us a negative, the x minus 3 gave us a negative, and so overall now that product should give us a positive. Okay, so that's what the table does for us, is it organizes it to say, okay, that first factor was negative, second factor was negative, and now the overall factors multiplied together should be positive. Now we need to do the same thing for each of our other intervals. Okay, so what value could I choose in the interval from 2 to 3? 2.5, okay? So again, I'm substituting that in. I'm going to have 2.5 minus 2, 2.5 minus 3. So that first one there, 2.5 minus 2, is that going to be a positive or a negative? That one's positive, so I put a positive in my table. 2.5 minus 3 is going to be what? That one's negative, so that gives me a negative in my table. How many negatives this time? 1, which is an even or an odd number. Odd, therefore, overall, this should be negative. That tells me the product down here is going to be a negative. Okay, now we need to test that final interval. So what can I choose between 3 and infinity? 4 works. So if we plug in a 4 now, we're going to have 4 minus 2, 4 minus 3. 4 minus 2, positive or negative? Good. 4 minus 3, positive or negative? Also positive. And so in this case, there are no negatives, right? Which is still 0, which is an even number. And so overall, this should be what? Positive. Okay. Right. So basically what that tells us now, if I go back to my number line, everything down here is going to be positive from here. Everything here is going to be negative from here. And then everything here is going to be positive from here. So we're only looking at that last line, right? The actual product of the two factors now. That's where I'm getting the signs for the number line. Now, do we care about positive or negative values in this case? So look back at your inequality. Do we want the values to be positive or negative? We want them to be negative, right? Because if you look back at the inequality, we want it to be less than or equal to 0, which means that we want negative values, right? So in this case, I only care about everything right here. That's the only place that I got negative values. So what would that interval look like this time where I got negative values? Okay, so it is going to be from 2 to 3. And now the only other question we have to ask ourselves is, are we including the endpoints or are we not including the endpoints? Think about this one. It was less than or equal to 0. Do we want to include the 2 and the 3 or not include the 2 and the 3? We are going to include them, right? And again, that's because of the equal to here. That tells us these are going to be closed circles at 2 and 3 and everything shaded in between. And so therefore, these are going to be brackets. And this would be our solution now. Okay. So I know that's a long process, right? But really it's our only way, because we can't just, once we factor it, we can't just set each factor less than or equal to 0. It's not going to work. It's not going to give us the right values. Okay, so we have to find the 2 and the 3 from the factors. We have to set up that number line, and then we have to test values in each of our intervals to figure out which intervals actually work. Okay, in this case, it was less than or equal to 0, so we only want the ones that are going to give us negatives. If it had been greater than or equal to 0, then you would take the positive values instead, right? And you would use those intervals. And then once we know where it's positive and negative, we generate our intervals, and then we have to always make sure, right, are we including or not including those endpoints? And we'll do some later where some endpoints are included and others aren't included. And so we have to keep in mind, what that's going to look like, and then when to use brackets and parentheses. Okay. Any questions on that one now? Okay, so we're going to stop there for today because I don't have time to start another one of these problems. So we'll pick up with that section next week. Again, you can at least be working on the 1.5 to 1.10 homework because we're done with 1.5 for sure. We've done a little bit in 1.8. Send me questions as you have them on those sections, right? And again, the goal right now is to try to get through the rest of this unit next week, and then hopefully have the test end of next week, or at worst, the following week. Okay. I'll hang out for a couple more minutes in case you've got any questions about anything. Otherwise, have a great weekend, and I will see you all on Monday.